So hey there, welcome back, and today we are going to discuss both the contest, the Biweekly Contest 185, which you are seeing in the in the screen, and the Weekly Contest 507. And talking about the contest questions, so the contest questions are pretty good. That teaches you a lot of stuffs, even on the first problem of I guess the Biweekly as well and the weekly as well. I have a very good concepts which you should learn and which you should know while solving such problems. So the contest problem are pretty good, and I will do my best to explain you, because I recently received one of the comment when the people saying that the explanation is not good. So I will try my best to actually explain what I have done in this particular question and how you should approach whenever you are solving such problems. Okay, so let's get started. So let's start with the first problem. So this is the biweekly first problem, which is create grid with exactly one path. Okay, so what the question asking us to do, that you are given a two integer m and n representing the number of rows in the column of a grid. Okay, construct any m cross n grid consisting only of the character dot and the hashtag. Dot represent the free cell and the hashtag represent an obstacle. Got it. A valid path is a sequence of free cells that start at the top left cell and ends at the right. Got it. What are the moves? Right, we can only move right or down. Return any grid such that there is exactly one valid path from top left cell to the bottom right cell. Got it. So if you see, we have two number of rows and three number of columns, right? And after that, what the problem asking, we have two condition which they have specifically mentioned. One, the grid only contains these two characters, and another thing is that after filling these two characters, we have to make a grid in a way that it only contain one valid path. Got it. So this is what they are asking. So if you see the example, that if the number of rows are 2 and the columns are 3, then our matrix is look like this. So we have put as you know, that dot represent an empty cell and hashtag represent a full cell, right? So if you see, we only have one path to actually reach from top left to top bottom, or from bottom right. So this is what a problem asking us to do. So it's easy problem, but pretty interesting, like how someone is going to actually approach this particular problem. So it is probably, it's mostly a pattern. There is nothing more about there is nothing more difficult. It is just a pattern. How? Let's see. Here's the thing, that let's say if I have created an 3 cross 3 matrix, right? So let me just write it over here. Right, got it. So what they are asking us to do, we should only have one valid path. So this is our constraint. Another thing, that we can fill matrix with dot, I should write it like this, or hashtag. So we are only allowed to put these two particular character inside our matrix, right? So if you see with the first example, if we somehow able to copy it from here, and let's see if it works. No, it is not working. So I'll just draw it right over here. I will use the other one to explain the another condition. So if you see, if we talked about the 2 rows and 3 column grid, so that is look like something like this, right? So we are allowed to fill only dot and hashtag, right? So how to actually think about it, right? So what are the possible ways? So if you see what we have done in the question, if you look over here, that this is the grid which formed. So we put hashtag here and hashtag here. Why? Because if you put hashtag somewhere else, even if you put hashtag over here at this particular position, it will also fine, because there is already also another one way to actually got to bottom right. But what is the reason that why we are putting over here? So let's see over here, that what you see in the problem is that the first hashtag is over here and the first hashtag is over here. So what our path is? Our path is simply like this, right? So this is our one path, and let's say just remove it, and we also can put hashtag here and here, then another path will be like this, right? So in this particular, we can have multiple options, right? But the thing is that it is working fine when we have the number of rows 2 and the number of columns 3. But we should think about something that will actually work even on the larger cases, right? So let's try to like simulate the same stuff on the 3 into 3 matrix. So as we did, we have done. So let's say I mark this one and I mark this one, right? So I'm talking about to reach from here to here, right? So it is fine, but still I also have to mark this one and this one, right? Because if I don't mark this one, then the another path would be like this, and there is one more path which is like from here, right? So you are getting the point what I'm talking about. So we have multiple ways to actually solve this particular problem and multiple ways to fill the matrix, but we try to fill in a way that will actually help us to fill a matrix in a way that we only have one particular path. So what the pattern which I notice is, maybe you have noticed it in a different way. So what the pattern which I have noticed, so let's undo it. So if you see the first case, so I'm already considering that whenever I'm going, I will always choose this particular pattern, right? I always want this particular pattern. So what I will do, what I have been doing over there, that after, if you just write it over here with the like indices as well, that, so let's say, let's create for the 2 cross 2, right? So what I'm thinking in the way that, sorry for that, let's say, so it's 0, write it with the help of this one, this is 0 and this is 1, and similarly this is 1, this is 0, 1 and 2, right? So this cell represents 0 0, this cell represents 0 1, 0 2, 1 0, 1 1 1, 1 2, right? So this is the represent. So what I actually want, like, and what I'm doing, that whenever I want to find a path, I will always choose this particular pattern. This is what I'm assuming. You can assume any other part as well, but I'm assuming in this particular pattern, right? So for that, what I'm doing is, for the first row, I'm always picking the second row, and from that, maybe let's say there are some more column also exist. So what I've been doing, I will putting all this row with the help of hash, right? And I'm just for the row, I'm putting all the hash over there, and for the column, I'm starting from the first column until the end, right? So this is the first thing which I have to do. So what I am doing, so I have done two things. First row with like second column, right? In case of column, I'm going from the first row, right? So this is what I have been doing. So I have done with this, and let's say let's come with this particular part, and let's say I have covered this one and I have covered this one, right? And I'm assuming that there is a path. Let's make a different color. There is a path from here to here, right? But here is a catch. We also have this particular thing over here, so we don't want this as well. So what another thing which I need to take care of, that I have done two things, right? I have covered this one and I have covered this one. Another thing which I have been doing is, except this particular path, whatever the whatever the cells are left, I will color, I will put hash there as well, right? So this is what I have been doing. So that when I will do this, then I will only have this particular path, which is the valid path which we want, right? So let's see the example with the 4 of 4, that will make more sense, right? So what I'm talking about, so let's see, this is the 4 of 4, this one, and this one, and similarly just ignore the part, right? So this is it. And what I'm saying, that what I have done, like for the first row, I will mark from here to here, and from column I will mark here to here. And for the third thing which I have been doing, except this particular path, whatever the rows are there, I will cover this till the first column or first row, right? So this is what I have been doing, which means I will cover this part, I will cover this part always, right? This is the part which I am going to cover always, right? So this is what I have been doing over here, and so that I can have a path which is valid from here to here, right? So this is the overall thinking about this particular problem. I know that this is an easy problem, but it actually give you a good understanding of the concepts, that you actually got to learn a lot of stuffs when you draw, when you write all those stuff. So this is the whole idea behind this particular problem. And if you see the code, so the code is also pretty easy, right? So I have created a character matrix. Why? Because what I have been doing, I'm just putting all the, like, first I'm creating a matrix and I'm putting all the characters which I want in the question to like put, right? So first I fill with empty because in the first case I only have the empty matrix, right? So now in the second I'm filling the row, which I mentioned that from the second row 0 to I've been filling with the hashtag. So this is what I have been doing over here. And why I have mentioned m greater than 1, the reason is let's say we have a value of number of column as 2, but we only have one row, which in that case our matrix is looking something like this. Our matrices look like this, which is assuming it's 3 number of rows, right? So in this case it already have a path from upper to lower, so we don't have to perform any number of operation, right? You can write the test case by your own self, so to get to know what exactly is happening. So this is what we have handled over here, and similarly for the column as well. And apart from that, this is the third case. This is the case where I have been doing from the lower side, like for this part, right? So this is what I've been running from here, and after that I'm just creating our matrix and creating my result, right? So this is the first problem, which is quite good. It's really interesting. See, everything is working fine, and the test case which I've been talking about, that if m is 1 and n is 4, then the output will be dot dot dot, which is an empty matrix, because we already have a path, we don't have to calculate it, right? So this is the first problem, which is quite good. I really enjoy, and the time complexity is O of n cross m, this because we are just running it till that particular time. So this is the first problem, which is really interesting. Let's move to the second one. Second problem is also interesting. Like, the contest question are really good, right? So let's see. So you are given an integer array lights of length n representing a position 0 through n minus 1 on a road. Got it. For each position I, if light v, where v is greater than, there is a working bulb at position I that eliminates every position from max of 0, like left to right they are talking about. And if light is 0, there is no working bulb at position I. A position is visible if there is eliminated by at least one working bulb. You may install additional bulbs, got it, at any position. Each additional bulb installed at position j eliminate position, got it. So what the problem is, that we have n number of bulbs initially, that we have bulb in a row, that we have a bulbs, assuming it like them. So we have bulb, and initially there what can be possible, that initially there are some bulbs which are active and which are off. So what they are asking, that let's say if this particular bulb is on, if this bulb is on, then it will cover both of the bulb, which is whatever the index of that particular bulb. Let's say index is I plus whatever the value of that particular bulb, right? So it will cover, and in precisely you can say it will cover both its left and both its right if they are come under the boundary. So this is what they are asking us to do. This is the case when there is already a bulb which is working, which is visible, right? And there is another case that you can also on some more bulbs as well, right? Which means that if you see, in this particular case we only have one bulb which is working, which is this one. It covers both of these bulb, but still we have these two places which is not visible. So in order to make them visible, we have to make them visible as well. So for that we also have to do that same. If you see, you means install additional bulbs, which we have to do. That will also cover j minus 1 to j plus 1, which means if we initialize this, let's say at the 0th position, if we at the 0th, then it will going to cover 0 minus 1 plus 0 plus 1. So it will actually going to cover 3 bulbs or 3 position, right? So this is what they are asking us to do. So at every position, if there is already a bulb, then we have that bulb will cover both its left and right, and if there are not visible bulb, then we have to additionally on some more bulbs so that we can cover all the remaining invisible as well. And what the task which we have to do, return the minimum number of additional bulbs are required to make every position on the road visible, right? So if you see, all are off. So what is the optimal way? So one optimal placement is install an additional bulb at position 1. So if we install a bulb over here, then it will cover both of these bulb. So it will cover both of these bulb, so which we have covered over here. And after that we still have one bulb which is not visible, so for that we have to do the same for the third bulb. Then it will cover this, the second position bulb is already visible, but still it cover both of them. Then after that all the bulbs are visible, so we only require two number of operations, right? So this is what the problem asking us to do exactly over here. So how to think about it and how to approach this particular problem. So initially when I was solving this particular problem, so like I come up with a brute force approach, right? Because that's the only thing which I came in my mind. But some people also suggested a certain term and certain technique which I use later on, but initially I also came up with the like brute force approach. I also not able to thought about the optimal, but after looking at my code and I got to know that okay, I can somehow like use some technique which I have already learned, so I use that. So I will explain you that as well. So what, like how we can actually approach this particular problem, right? So there are two possibilities if you see. So what are the possibility? First, either all bulbs are off or not visible. This is the first possibility, right? And what is the second possibility? There are some bulbs which are active, right? So these are the only two possibility, right? In this particular example it is coming under the first possibility, right? But there may be possibility that we have some bulbs which are on, right? So we need to take care of that. So remembering this particular fact, so I know that there may be a possibility that some bulbs are active, so why not utilize those bulbs and make visible and try to cover all the bulb which is present in their neighbor. So this is what exactly what we are doing, what we will do. For example, let's change this test case to like this, right? So you see the second bulb is on and it will cover both of the bulb, 0th one and the third bulb, right? So this is, it will cover. And let's take another bigger example. Let's say our array is like this, right? So let's assume, and if there is certain one, right, so it will cover its neighbors, right? So what we'll do, we will come under the second part, which is there are some bulbs, so we utilize them and we make them visible. Let's say it will cover this one, it will cover this one, and it will cover this one. So we still have this particular 0 which is the bulb which is not visible, but just with the help of already visited or already you can say already on bulbs which help us to make other bulbs active as well, right? But we still left with some bulbs, and that case come under this particular case. That means we have still some bulbs which is not on. So for that we have another condition, that we have to install additional bulbs, right? So in this case, as we see, so this is the bulb which is not got active, so we install one bulb over here, then everything become already visible, right? So like write it over here that this will cover this one, got it? This will cover this one, and this will cover this one. So we still left with the one, right? So we have to additionally install one bulb over here. So how many number of operation we require? We only require one operation, because everything is already covered by our already on bulb, right? So this is what we have to do. And another thing, that while processing it, we are not marking 1 0, where we need something which will tell us that okay, this is already up, on, or visible bulb. And for that we will use something called visited, that will actually help us in this particular scenario, right? So this is what the thing which we have to do. Let's see the code is also easy, but the thing is that I have implemented a difference array stuff, but let's just ignore that stuff, right? So what we have to do, let's say there is a range, right? So let's write the brute force over here, then we will move there so that it will not make confusion for you, right? So let's say our array is 1 our array is 1 0 0 1 0, right? So this is, let's say, an array, and we are at let's say we are at this position which is inactive. So it will, how many number of like position it will going to cover? So as we see the formula which we see, it is going to cover I, which is the index of that particular and what is the value of that particular. So this number of bulbs it will going to cover, which means it will cover all the bulb which is coming inside his range and this range, right? So this is what it will going to cover. So this is what we have to do. So first thing what we are doing, we are uh, iterating over the array and picking the bulbs which are active, which are visible, right? We are picking those bulbs which are visible, and we are marking all those bulbs which are visible with the help of the current bulb which we use to mark that one visible, right? So this is what we are doing over here, right? So if you see the code, so inside the code I have written something like this, but instead of this, if I talked about the brute force approach, so in that case, instead of doing this, we have to run a loop which is from left, which is less than equal to right, and this one, and after that we just have to mark that particular index as true, which indicates that it is visible, right? So this is what we have to do, and with the help of what we have done with the first part, which means if there are some certain bulbs which are active, then with the help of them we are going to active all those neighbors which are come under this range, right? So this is what we have done over here, and after that once this is done, then we simply iterate over our visited array and we check if it is visited or not. Right now I use different because there is a different approach, but let's say a difference array conducted, and arrays look like something like this. Okay, so we still left with two places where we haven't marked them visible. So these are the additional installs which we have to done. So this is what we are doing. Instead of this, if we write like visited of I is true, which means it is already visible, then we don't have to do anything. But if it is not, then we require extra bulbs as well, and when we active that particular bulb, then it will going to mark 3 different bulbs as well. It will cover both their neighbor as well. So this is what we are doing, and after that we are just simply returning the extra bulbs, right? So this is the like the brute force one. Why I'm talking about brute force one? Because if you see, for every left to right, we are iterating from left to right and marking a visited array, right? And which is not an efficient approach, right? If you know about some ranges queries, so whenever we talked about ranges query, then there is always a point and always a scenario of using difference array. So what I have done over here, so I will just explain you in this code, right? So let's make it undo. So you already know that how difference array technique is work. If you don't know, then do let me know in the comment section. I will explain it in a different video, right? And we already know that how to deal with it, because what we are doing over here, we have a certain range, right? So in a range we are performing certain number of operation, right? So this is the range. So this is what we are doing inside the difference array technique, and after that I am just calculating, as we know that how if you know how exactly the difference array technique works, then you will able to understand what I have been doing over here. And after that, the same thing, if difference array is greater than 0, then it is already, otherwise we need an extra bulbs, and this is how the code of this particular problem is look like, which is working fine. And this is also pretty interesting problem. It will actually give you a lot of good understanding of the different concepts. So do let me know in the comment section that if you not know about difference array techniques, I will love to make a separate video on that, because maybe you are not able to understand whatever is happening over here, because this is the whole concept of differential technique. So this is it about the second problem, which is quite good. Let's move to another problem. This is weekly contest. This is the first problem, by the way, right? This is easy, and this is quite easy. The issue which I faced initially, that okay, because as we know, whenever there is a like there is a concept, or there is a discussion related to distance, Manhattan distance, we always think about something called recursion and graph as well. So initially I also did the same mistake, right? But yeah, that's a learning, not a waste of time. So what they are saying, that you are given a string moves consisting of the characters UDL or and there is a dash, right? Starting from the origin, each character represents one move on a 2D plane. Got it? Move 1 by up, left, right. Okay. And dash can be independently replaced with any one of them. got it. We have to return the maximum Manhattan distance from the origin that can be achieved after all move have been performed. So this is what we have to do. So see the first example. Then from the origin we'll move to left, which is -1 to 0. Then dash, we can use dash as any of this particular character or any of this particular move, right? So here we are using it as like downwards, which give us as -1 as -1. Then we use d as -1 and -2, and then treat dash as L. After that we reaches at a point which gives us the value as 4. So this is the maximum Manhattan distance which we can form. Okay, it's quite clear. So initially what I thought that okay so what the mistake I did, so I know the first character this, the second is dash, then D, and then dash, right? So initially what I thought that okay, I know about the moves which are there, but for the dash I don't know what to pick. Like don't know what to pick. I actually don't know what to pick. So in that case what should I do, right? I know for the L I have to move like from the left, but for the dash I don't know what I have to do, right? Because initially from where we are starting from origin, which is, I think I should write with the help of this one. We are starting from 0 0, right? So for the 0 0 I know I have to move left, but let's say if the starting is itself is dash, so from 0 to 0 where should I move so that I get a maximum Manhattan distance? So here I thought I have multiple possibilities that because in the problem statement that clearly mentioned that you can use dash as any of the character, u d, right and left, right? So I don't know, so I thought why not try all the possibility and pick whatever giving is the maximum. So this is the first thing which came to my mind, and I implemented. I got a TLE, and then I got to know that okay, this is not the correct approach which I should use. So if you see like firstly if you're solving, then you are also going to come up with this particular approach that why not use recursion and try all the possibilities, because we don't know when we are going to get a maximum value. So this is the same thing which I have done with this particular problem as well. But then I realized okay, do I really need to do this particular computation? Like do I really need to do this? And when I look towards the constraints, so constraints are also 10 to the power 5, which is extremely high when I'm going to use recursion. So I thought, do I really need to do this? Then I got to know okay, I actually don't need to do this. Why? Let's just see that I actually don't know where to use dash, either use up, down, left, right. I actually don't know. So what I thought, why not whatever the moves I have given, I just utilize them, and after that whatever the dashes are there, I should keep track of their counted and just move that particular into one direction. So the thing is, let's say initially I'm at 0 0, so when I'm moving left, then I move like -1 and 0, and I'm not considering dash, I'm just considering D, then which is down, then I'm moving 1 as +1, which is going to be, just a second, yeah. So I am moving my, so this is what I've been talking about. So I'm going left. Okay, so this is not something which I thought. I am at a like 0 0, right? And after that I move to left, which is -1, 0, right? And now I'm moving to like +1, which is -1, 1. So this is my current position where I have been right now, right? So I ignored the dashes and I just use the movements, right? And I'm at this particular position. So what I'm thinking and what I thought that okay, let's say this is my origin, so I move to left, I move to down, right? But I don't know where to utilize dash. So why not just after that I thought, why not, like I till this point I have utilizes my move, right? And after that I should do I just have to find the maximum, right? And have to calculate the absolute value. So why not just move into one direction instead of thinking what to take and what not to take? Why not just the number of dashes we have, just move that position to this particular downwards, like at any position wherever you are moving, it will also give like from origin to this, the distance is always maximum. So this is what I thought, that why not we can use it in that particular way. So what the thing is that I know this is my origin, right? I move to left, I move to down, right? So I just calculated the distance, but I already also have these dashes. So why not use light them? And in the question they already mentioned that we can use it for anything, like any move. So I am choosing it to go down, and now I'm calculating the distance, which is also a maximum. So this is the whole idea behind this particular problem. So you also got to learn when you write it by your own self that what I'm talking about and how this make more sense, because initially I also did the mistake while taking using the recursion, which is the mistake, right? If you see, I'm counting the dashes. I have x and y, right, which is denoting the coordinates, running towards the characters matrix, the string, based on the like movement, and based on the character I'm just moving my x and y, and also counting the dashes as well. And what I'm doing over here is that if I'm at particular position, so why not go till down, or go like either increase that particular x, either decrease that particular x. This is what we have done over here, that in this case we have decreased it till, and right, either we can increase it, that will also make sense, right? So this is what we are doing over here, and after that we are just returning the value of x. You can also apply it with y as well. There is no constraint to just apply it to x, but yeah, you can also apply it to y as well. So the time complexity become O of n, right? And previously it was 2 to the power it's not 2 to the power n. At every position we have 4 possibilities, that it's if we have a dashes, in those cases we have a 4 to the power uh, uh, considering the number of dashes are n, then 4 to the power n number of possibility, right? Now we turn it to O of n solution. So this is the problem in the biweekly contest. In the biweekly contest, it is also interesting. It teaches me as well the lot of concept, right? Let's discuss about the another problem, which is valid subarray with matching sum digits. It's easy problem and it's quite good problem, right? So you are given an integer array nums and integer x. A subarray is considering a valid if the sum of elements satisfy both of the following condition. The first digit of the sum is equal to x. The last digit of the sum is equal to x. Return the number of valid subarray. So what they are asking, that we have a subarray. Let's say the subarray is 1, right? And we also have the value of 1. So they are saying that, let's say we form our subarray with the help of 100 plus 1, right? Let's say the subarray become, right, 2. So they are asking the first digit of the sum should be equal to x, and the last digit sum should be equal to x. So this is the two condition, and if the sum can satisfy the condition, then this is be the part of our answer. So this is straightforward, like we just have to generate all the subarrays and just have to check the first and the last digit of that particular number. So this is the straightforward what I have been doing over here. I'm just generating all the subarrays, calculating the sum, and I have called a valid function, which what it is doing. With the help of this, I'm just checking if the first digit is equal. If the first digit is not equal to x, then there is no point of calculating the rest. Then I'm just returning false from here. Otherwise I'm making a false. Why? Because somehow I got to know what is the first digit, so that's why I'm using a flag. You can use any other approach as well, and I'm running it till 10 because I want the first digit. That's why I have used this particular condition. And after that I'm just checking if the last if the first digit is equal to x. If it is, then return true, otherwise return false. So this is the second problem of weekly contest, and the contests are pretty good. The time complexity of this one is O of n square multiply by the digit, you can say multiply by d. This is the time complexity of this particular problem. So this is the whole contest problem and the solutions of this problem, and I hope you are able to understand what I taught in this particular video. And if you are not able to understand, do let me know in the comment section. If you need any clarification, if you need something which I should improve, then do let me know in the comment section. I will love to work upon all of that. And yeah, I try to give my best to explain you as much as I can, so that you will got to know and you will learn a lot of stuff from my videos. And if you are able to understand, then do like the video, do subscribe to the channel, do share with your friends, so that they also got to know about the channel. They also learn some good stuff as well. And this is it for the today. And sorry for the late, because I have something some traveling commitment so that I'm uploading a video on a late. But yeah, this is it for the video, and I hope you like the video. Then bye bye, take care, keep grinding, keep learning. This is it, and bye bye, take care.